Hello, welcome to my recorded classes. Today, this class we are discussing the section number 2.3 from the module matrices and determinant. So, before starting the section, all of you please subscribe my channel for getting more updated classes. Okay, so let's start the content. So this module 2.3 section matrices, basic operations and special type of matrices and matrix transpose. So these three idea we are discussing here. So mainly we have what are the basic operations in matrices and what are the special types of matrices, and we need to study what is matrix transpose. Okay, so we will go to first basic operations. Okay, basic operation means how to add two matrices, how to subtract two matrices, and how to multiply equal to. What is the meaning equality? Okay, so addition we need to discuss, subtraction, multiply, and equality. What is the meaning? Two matrices are equal. So let's start with the basic operation, addition and subtraction of matrices. So for example, A equal to matrix 2 minus 3 0 1 2 minus 5, and B equal to matrix 3 1 2 minus 3 2 5. See, you can see both matrix 2 rows and 3 column, 2 by 3 matrix. Here also 2 by 3 matrix, correct? Now to add these two matrices, matrix A plus B equals, add the first number with the first number, first matrix first number with first number in the second matrix. So 2 plus 3 you will get 5 here. Same way we are going second number, add second number here minus 3 plus 1, that is minus 2. Same way we are continuing 0 plus 2 2, 1 plus minus 3 minus 2, 2 plus 2 that is 4, minus 5 plus 5 is 0. So this is the addition of two matrices. Okay, how to add two matrices, A plus B matrix. Now when we are going to subtraction of matrix A minus B, same idea, just subtract the number, first number that is 2 minus the first number in the second matrix, 2 minus 3, that means minus 1. Same way another numbers, minus 3 minus 1, it is minus 4, then 0 minus 2 minus 2, 1 plus 1 minus minus 2, that means 1 plus 3, because 1 minus subtraction minus and number is minus 3, 1 minus 3, that means 1 plus 3, that equal to 4. Okay, and 2 minus 2 0, minus 5 means minus 10. So these are the addition and subtraction of two matrices. Now generally when we are taking A plus B matrix and B plus A matrix, both will be same, because A plus B means we are doing for the above example 2 plus 3 5. Now if you are doing 3 plus 2, that also will be 5, correct? So A plus B and B plus A generally it is same, but A minus B and B minus A not same, sign difference will be there. So A minus B not equal to B minus A, because 2 minus 3, here we go to minus 1. But if you are taking B minus A, that means 3 minus 2, it is only 1. So sign difference will be there. So this is the addition and subtraction of two matrices. Now we will come to the multiplication of a matrix by a number. Okay, that means multiply case, we have two cases, a number and a matrix multiply. Okay, for example this is a number and this is a matrix. So how to multiply a number, a matrix, and another one we need to study how to multiply two matrices. Okay, one matrix multiply another matrix. So this is matrix multiply another matrix. Okay, so how to multiply, what will be the answer here and what will be the answer here? So multiply operation means we have to multiply operation, multiply a number with a matrix and multiply two matrices, matrix multiply another matrix. Okay, so first we will consider number and a matrix, how to multiply. So that is why here it is multiplication of a matrix by a number. So 6 is the number here, correct? 6 is the number here, and a matrix 1 2 4 minus 3. So what we will do is each element of the matrix multiplied with the outside number. Okay, like this. So 6 multiply 1, 6. 6 multiply 2, 12. And 6 multiply 4, 24. 6 multiply minus 3, minus 18. So that is the multiplication of a matrix by a number. Now, next operation, equality of matrices. Equality means equal to. When we are telling two matrices are equal. For example, A equal to matrix P, Q, R, S. A 2 by 2 matrix. And matrix B equal to 3, minus 2, 0, 14. Another 2 by 2 matrix, correct? Now, these two matrices are equal. That means A equal B. What is the meaning A equal B? Actually, the first number here should be same as the first number here. That means what will be the P value we are getting? P value equal to 3. Same way, second number should be same as the second number. Q equal minus 2. Third number should be same as the third number here. R equal 0. And fourth number will be same, S equal to 14. So this is the meaning of the equality of two matrices. For if you want to find some missing number, we can use this one, correct? Two matrices are equal, some numbers are missing. We can equate like this and we can find what is that missing number. So this is the meaning equality of two matrices. I hope you understood this idea also. Now we will go to the multiplication of matrices. So multiplication of a matrix by a number, now we discuss it. Now how to multiply two matrices? This is what the important idea here. How to multiply two matrices. For example, this is the basic rule we need to be careful in our mind. All the matrix we cannot multiply. So when we can multiply two matrices? Okay, this is what important. When we can multiply two matrices. For example, first matrix A, order is M by P. M by P. First matrix order is M by P. 1 by 2, 2 by 2, like that. Okay. And second matrix B, order is P by N. Second matrix order is P by N. Now, what we need to check is that if we want to multiply these two matrices, as I told you, some matrix only we can multiply. So, when we are multiplying two matrices, check the second number here and the first number here. Okay. First matrix order, second number, and second matrix order, first number. This should be same. Then only we can multiply. Otherwise, we cannot multiply. Okay. First matrix order, second number, and second matrix order, first number should be same. Now, if it is same, then we can multiply. Now, the answer matrix, that means A multiply B matrix means the order should be, here is the first number, and here should be the last number, here last number. So M by N matrix, we will get an M by N matrix as the answer. Okay, so keep in our mind that one. So A M by P, B P by N means AB matrix M by N. That means the first number here, last number here. That is the order of the new matrix, AB matrix, correct? Now, for example, here you can see one example, that is A equal to matrix 6 minus 2 3 minus 4 2 5. That means what is the order of the A matrix? It is 2 rows, 3 column, 2 by 3 matrix. Now we can check what is the matrix B. Matrix B means 2 minus 3, 4 minus 5, 1 minus 6. That order, how many rows? We have 3 rows and 2 columns, correct? Now we need to multiply these two. A multiply B matrix. Can we multiply these two matrix? Yes. Why? Because here the second number and here is the first number same, correct? Both are same. So we can multiply that two matrix. So if we are multiplying, we will get A B matrix. Okay, A multiply B matrix. What will be the order of that matrix? As I told you, the first number here and the last number here. That means it will be a 2 by 2 matrix. Okay, 2 by 2 matrix. That means 2 by 2 matrix, 2 rows and 2 columns will be that matrix. Okay, so here I already written how to multiply, multiplying these two matrices. So what we will do is, okay, just to take the first matrix and I have the second matrix here. I will show how to multiply this one. For example, 6 minus 2 3, 6 minus 2 and 3, minus 4 2 5, 2 5 and 2 minus 3, 2 minus 3 second matrix, 4 minus 5, 4 minus 5 and 1 minus 6. 1 minus 6. Now, when we are multiplying these two matrices, correct? As I told you, it should be a 2 by 2 matrix, correct? 2 by 2. 2 by 2 means first row, second row. 2 rows and 2 column. Column number 1, column number 2, correct? So, what are the numbers here we are getting? Here see, first row, first column. R1, C1 multiply. Okay, how we are getting that one? See, this is coming on first row, first column. That is R1, C1. Okay, R1, C1. Now, same way we need to calculate here. First row multiply with the column number 2, R1, C2. Then second row multiply column number 1, second row with the column number 2. This is the matrix we need to calculate here. That means we need to calculate these 4 number. First R1 row multiply with the column number 1, R1 row with the column number 2, R2 with the column number 1, R2 with the column number 2. Correct? I hope you understood. R1, R2, C1, C2. So first what we will do, here is the first row, first column. So here we need to calculate R1, C1. Now same first row but second column. So R1, C2. After that second row, first column. Second row, second column. This is the idea behind the multiplication of these two matrices. Now we will go to that one. Okay, we will go to that multiplication. You can see, so first matrix take rows, first row, second row. Second matrix we take columns, column number 1, column number 2. Okay, first matrix we are taking rows and second matrix we are taking columns. Now what we will do, the first row here. See the first row. Multiply with the first column here. See, that is the meaning R1, C1. R1, C1. One or two case I will show here. Okay, R1, C1 equal to, first row means 6 minus 2 and 3. Multiply with the first column 2, 4, 1. Correct? Now how to multiply these two? You can see first number here multiply with the first number here. That means 6 multiply 2 plus second number multiply with the second number minus 2 multiply 4 plus third number multiply third number 3 multiply 1. I hope you understood how to calculate that one. First number multiply with the first number, second number here multiply with the second number, and third number here multiply with the third number. After that adding, correct? So that we will get what is R1, C1. Okay, so that is what I wrote here. See, 6 multiply 2 plus minus 2 multiply 4 plus 3 multiply 1. So you will get 7 here. See, first number. Now same way we need to calculate all other. R1, C2, first row with the column number 2. First row we need to multiply this column, column number 2. That is the R1, C2. Once you finish first row, we can go to the second row here. See, second row. Second row with column number 1 and second row with column number 2. Okay, second row with column number 1 and second row with column number 2. So this is the idea of multiply. First row with column number 1, first row with column number 2, then second row with column number 1, second row with column number 2. So we will get all these 4 numbers. That means the 2 by 2 matrix, 7 minus 26, 5 minus 28. Okay, so this is the idea of multiply two matrices. Okay, so I hope you understood how to multiply two matrices. Now, for example, here one example is there. We can do this question, for example, so that you will understood how to multiply two matrices. Answer also I am given here, but we can check. What is the first matrix order? First check. A matrix. What is the order of A matrix? 2 by 2. Correct? Now what is the matrix B order? Matrix B order 2 by 3. Now can we multiply these two matrices? Yes, because the second number here same as the first number here. Correct? So what will be the order of the answer matrix AB matrix? The first number here 2, last number here 3. 2 by 3 matrix. It should be a 2 by 3 matrix. So what is that 2 by 3 matrix we are calculating now? Okay. So A multiply B matrix equal. The first matrix we are calling A. Second matrix we are calling B matrix. So AB matrix means it should be as per 2 by 3 matrix, correct? That means we have 2 rows R1, R2, 3 columns, column 1, column 2 and column 3. So what are the numbers we need to calculate? First here R1, C1, first row with the first column, R1, C2, first row with the second column, R1, C3, first row with the third column, then R2, first column, R2, C1, second row, second column, second row, third column. So this 6th number we need to calculate, correct? We need to calculate a matrix, this 6th number, correct? So here one number, second, third, and here also 1, 2, 3. The 6th number we need to calculate one by one. So first we will start R1, C1. First we are calculating first row with the first column, R1, C1. So which is the first row? The first matrix, first row. This is the row number 1. Which is the first column? This is the column number 1. Second matrix, column number 1. So what we need to multiply? 2, 4. First row. Multiply first column 1, 0. Now as I told you how we are multiplying first number with the first number. 2 multiply 1 plus second number with the second number. 4 multiply 0. Correct? So you will get answer equal to 2. So that is the first number here. Number 2. Hope you understood. Now first row with the second column. Column number 2. First row same, that is 2, 4. But column number 2 means this one. Minus 1 and 2. Minus 1, 2. So how to multiply? First number with the first number. 2 multiply minus 1 plus second number with the second number. 4 multiply 2. Correct? So 4 multiply 2 means 8. 8 minus 2 multiply 1 minus 2. 8 minus 2 means 6. That means the second number here 6. Okay. Now the third number R1, C3. First row with the column number 3. First row 2, 4. Column number 3 means 5, 6. 5 and 6. Okay. This is column 3. This is column 2. Now see 2 multiply 5. First number with the first. Plus 4 multiply 6, second number with the second number. So 2 multiply 5 means 10, 4 multiply 6 means 24. So we will get 34. Correct? So here we got 34. Now same way second row now we are going. First row we done. Now we will go to this row, second row. Okay? So second row with the column number 1. So you can see the second row. Second row means 1 minus 3. Multiply column number 1. Column number 1 means 1, 0. 1, 0. That means we can write first number with first number plus second number with second number. So you will get 1. Correct? So we can write the number here equal to 1. Now same way another 2. We need to calculate R2, C2. Second row means 1 minus 3 multiply column number 2. Minus 1, 2. So minus 1, 2. So multiply here 1 multiply minus 1 plus minus 3 multiply 2. That means minus 7. So we can write here minus 7. Now same way R2 with C3, second row with column number 3. So second row means 1 minus 3 multiply column number 3. That means 5, 6. 5 and 6. That means 1 multiply 5 plus minus 3 multiply 6. So that you are getting minus 13. So you can write here minus 13. So this is the multiplication of two matrices A and B. A multiply B equal to. I hope you understood how to multiply two matrices. Now we will do more question in the exercise part. Now we will go to the discussion of special types of matrices. What are the special types of matrices? So first type, zero matrix or null matrix. Always we are represented by capital O. Okay, zero matrix or null matrix. Zero matrix means a matrix all the number 0. That is the meaning zero matrix or null matrix. Okay, so 0, 0, 0, 0, 0, 0. See, first matrix 1 by 2 matrix, second matrix 2 by 2. All the elements are 0. That is the condition. In a matrix, all elements are 0 means that is we are calling zero matrix. Now, second one, row matrix. Row matrix means a matrix having only one row. Only one row. For example, matrix 4, 1. See, only one row but two columns. Correct? Row only one. But here column number 1, column number 2. So only one row. That type of matrix we are calling row matrix. For example, here one row but 3 column, 1 by 3 matrix. Only one row. Now, column matrix. Column matrix means a matrix having only one column. For example, see only column number 1. But here row number 1, row number 2. We have two rows but only one column. Here also only one column but row number 1, 2 and row 3. So 3 by 1 matrix, correct? 3 by 1 matrix. So you can see here the first one row, but column how many, no issue. Here row how many, no problem, but column should be 1. Okay, so this is the row matrix and the column matrix. Now we will go to the next category, fourth one, square matrix. When we are telling a matrix is a square matrix. Square matrix means a matrix number of rows equal to number of column. Number of rows equal to number of column. That means, see, 1 by 1 matrix. Row number and column number same. 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. Like that matrix we are calling square matrix. Number of rows equal to number of column. So if it is a square matrix, for example 1 by 1 matrix, order you can write in a single number, order 1. Order 1 means order if you are getting single number, meaning is that is a square matrix of order. For example 1 means 1 by 1. Now order 2 means what is the meaning? It is a square matrix of order 2 by 2. Order 3 means it is a square matrix of order 3 by 3. So if it is a square matrix, we can write order in a single number. Now what is the meaning diagonal of a square matrix? See, diagonal means this number. This number we are calling the diagonal of a matrix. For example, see here matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 3 by 3 matrix, correct? Now as I told you, diagonal of a matrix means this is the diagonal. This we are calling diagonal, or we can say main diagonal. There are two diagonal, so this is diagonal or main diagonal. Now what is this second diagonal is that these three number. These three numbers we are calling off diagonal. Okay, off diagonal. So main diagonal or diagonal, and second one is the off diagonal numbers. 7, 5, 3, that is the off diagonal. 1, 5, 9 is the main diagonal number. So this is the idea here, square matrix and the diagonal of a matrix. Now triangular matrix. Okay, triangular matrix. So you can see when we have one square, correct? So we can form like a two triangle. One triangle here, second triangle here. This triangle we are calling upper triangle. This is we are calling lower triangle. Okay, upper triangle and lower triangle. Same way here, see, in a matrix we are created two triangle. One is the top side, one is the lower side. If top side we have number, down side number 0. For example, here number 0, here number 0, here number 0. That matrix we are calling upper triangular matrix. So upper triangular means down to the diagonal. Diagonal number means 2, 8, 1. So down to the diagonal 3 numbers, 0 means that matrix 3 by 3 for example. Okay, these three numbers 0 means that is we are calling upper triangular matrix. And if these three numbers 0, we are calling that matrix as the lower triangular matrix. So keep in our mind upper triangular and lower triangular. Upper triangle means diagonal downside 3 number 0. Lower triangular means diagonal upside 3 number 0 is lower triangular matrix. Now another classification is diagonal matrix. See, sixth one is diagonal matrix. Diagonal matrix means you can see the top 3 number diagonal should be 0 and down 3 numbers in the diagonal should be 0. This is we are calling diagonal matrix. Okay, diagonal matrix. So upper triangular, lower triangular and diagonal, these three are connected. Top side only 0, you can see downside only 0, upper triangular, top side 0, lower triangular, up and down 0, it is calling the diagonal matrix. Now keep in your mind this idea. Okay, for example, see, I am writing a 3 by 3 matrix here. First number A11, A12, A13. We are studied general form in 2.1 section. This is A21, A22, A23 and A31, A32, A33, correct? Now, what are the diagonal number? You can see these three are the diagonal number, correct? Now, upper triangular, a matrix is upper triangular. What are the number 0 here? Upper triangular. Upper triangular means this number should be 0, A21 should be 0 and A31 equal to 0 and A32 equal to 0. These three number, correct? Now, lower triangular matrix. Lower triangular matrix means what are the number will be 0? A12 0 and A13 0 and same way A23 0. A23 equal to 0. These three number, correct? So upper triangular, these three number 0, lower triangular, another three number 0. Now we can write a general condition how we are identifying upper triangular and lower triangular generally. So for example here A21, A31 and A32, correct? See here I and j, you can say the suffix number. First suffix is the big number 21, 31, 32. That means Aij equal to 0 when I greater than j. I number is the bigger number 2 and 1, 2 and 1, Ij, correct? So upper triangular condition in a matrix is Aij 0, I greater than j. Now when we are going to the second one, see lower triangular matrix, you can see the suffix 1 2, Ij, correct? 1 2, 1 3, 2 3. Second number is the bigger number. So how can we write that one? Aij equals 0 when I less than j. That means j is the bigger number. This is the condition for the lower triangular matrix. Now same way I want to write the diagonal matrix, correct? Diagonal matrix. Diagonal matrix means this upper portion 3 number 0, down portion 3 number 0. So only non-zero number what? A11. I shown one example here, correct? Yeah, this one. One example I already shown here. See the diagonal number only we have. Upper number 0, down number should be 0. That means when will be Aij 0? Aij equal to 0 when it will be Aij equal 0 when I not equal to j. I not equal to j. I equal to j, what happened? What is I equal to j? A11, A12, A11, A22, A33. See A11 diagonal number you can see. 11 means I and j same. 22 I and j same. 33 I and j same. All other cases, that means I and j not same means should be what will be the value 0. That is the matrix we are calling diagonal matrix. So these three meaning, okay, just to note, Aij 0, I greater than j means upper triangular. Aij 0, I less than j means lower triangular matrix. And Aij 0 when I not equal to j means diagonal matrix. So this is the sixth classification. Now we will go to the seventh classification. I hope you understood up to this. Now seventh classification, unit matrix or identity matrix. Unit matrix or identity matrix. Always we are representing capital letter I. Okay, I is the unit vector. Unit matrix or identity matrix. Now what is meaning I actually? I means it is same diagonal matrix. You know what is diagonal matrix? Matrix, only diagonal we have numbers, correct? All other position 0, correct? Now identity matrix means this diagonal number all it should be 1. That is the condition of identity matrix or unit matrix. For example, see what are the diagonal here, you can see 1 1 1. See unit identity 1 1 on the diagonal. Top side 0, down side also 0. See 1 0 0 0 1 0 0 0 1. This is the identity matrix of order 3. 3 by 3 identity matrix. 2 by 2 identity matrix means 1 0 0 1. The diagonal number should be 1. Downside 0, upside 0. That is the meaning unit matrix or identity matrix. 1 by 1 identity matrix means same 1. Same 1. Okay. So this is the idea unit matrix or identity matrix. Okay. Now we will go to the transpose of a matrix. What is the meaning? Transpose of a matrix. Transpose of a matrix we are representing a power capital T or a power small t. A transpose. Okay. Now what we do for that one? Interchange rows and columns. For example, see A equal to matrix 3 1 minus 5 12 7 6. We need to calculate A transpose. So what we will do? A transpose. Take the first row here 3 1 minus 5, write it as first column 3 1 minus 5. Second row take, write it as second column, second row number 2, write it as column number 2. Okay, so first row going to first column, second row going to second column, then it is calling the transpose of a matrix or A transpose matrix. So for example, see A equals matrix 1 2 3 4 5 6, correct? Now we can write what is the A transpose. What is the A transpose matrix? You can assume equals matrix first row we can take first 1 2 3, write it as first column 1 2 3. After that take the second row 4 5 6, write it as second column 4 5 6. This is the idea of the transpose of a matrix. Idea of transpose of a matrix, A transpose. Hope you understood that one. Okay, now we have some small properties or rules. You can see A transpose, all transpose should be A. First we find A transpose, then one more time transpose. When we are finding, we will get the original matrix. So A matrix, A transpose, all transpose equal to A matrix. Now another 2-3 points are important. A square matrix is said to be symmetric matrix. Symmetric. When we are telling symmetric matrix, A transpose should be A matrix. Okay, A transpose when we are finding, we will get the same matrix, A matrix itself. That is the condition for the symmetric matrix. For example, see A equal 3 5 5 minus 7. A equal 3 5 5 minus 7. What is the A transpose you can do? A transpose equal matrix first row, write it as first column 3 5. Second row, write it as second column 5 minus 7. A transpose. Now you can check these two matrices are same or not. Same matrix, correct? A and A transpose matrix are same. So it is calling symmetric matrix. Now the next idea, when we are calling a matrix is Q symmetric. Okay, when we are calling a matrix is Q symmetric. A transpose equal to minus A, opposite of A, minus A transpose value. For example, here A equals 0 5 minus 5 0. Suppose when we are calculating A transpose equal, what is the A transpose? First row 0 5, write it as first column. Second row minus 5 0, write it as second column. Now you can compare these two matrices. Both matrices are not same, correct? First number 0, here also 0, but here 5, here minus 5, opposite. Here minus 5, here plus 5. Here 0, 0. So what happened? Just opposite sign. Same number but opposite sign, correct? Opposite sign. So this type of matrix we are calling skew symmetric matrix. Now when we are seeing the skew symmetric matrix, diagonal number always 0. Diagonal numbers will be 0 in skew symmetric matrix. So keep in our mind, this is the idea of skew symmetric matrix. Now fourth one, a square matrix is said to be orthogonal. Orthogonal matrix, okay? A square matrix is said to be orthogonal. A multiply A transpose equal to I. That means A matrix multiply with A transpose matrix. You know how to multiply two matrices. We discussed this section. So when we are multiplying these two matrices, A matrix and A transpose matrix, you will get answer as the identity matrix. What is the identity matrix? Just now before discussed, 1 0 0 1 or 1 0 0 0 1 0 0 1, like that one, correct? So A multiply A transpose equal to identity matrix. If you are getting that two matrices are orthogonal matrix, okay? A matrix is orthogonal matrix. So I hope you understood this idea, these rules. Now we will come to the questions. Exercise 2.3, first question. Now all this idea we are discussing in questions. First question. First question, that is find the values of x, y and z from the following matrix, okay, from the following matrices. Find the values of x, y and z. For example, first one, matrix 4 3 x 5 equals matrix y z 1 5, okay, y z 1 5. What are the values of x, y and z? That is the question here. So what is given here? This matrix equal to this matrix, correct? Two matrices are equal. Two matrices are equal means we discussed here, first number should be same as the first number, second number should be same, third number should be same, fourth number should be same. So what are the first number? 4 here equal, what is the first number? Y. So y value we got, y value equal to 4. Now second number should be same. What is the second number? 3 and z, correct? So 3 equal to z number also we got. Now third number x1, so x equal to 1, we got the x number also. 5 equal to 5, that same only. So x number 1, y number 4, z number 3. That is the question we need to do there. What are the values of x, y and z? I hope you understood that question. Now second question, we will go to the second one. X plus y 2, 5 plus z, xy equals 6 2 5 8. That means this matrix equal this matrix, correct? This matrix equal to this matrix. So first number, what are the first number? X plus y equal to 6, correct? Now what is the second number? 2 equal to 2, same. Third number 5 plus z equal to 5. Fourth means x multiply y equal to 8, correct? X multiply y equal to 8. Now from this here we can find the z value. Z equal to 5 take to the next side. So 5 minus 5, that means z equal to 0. Z number we got. Now we need to calculate x number and y number, okay? So what are the condition now? Balance x plus y equals 6, correct? And xy equal 8. X multiply y equal 8. Now what we will do here, from here easily we can take y value. Y value means 6 minus x, plus x take to next side, 6 minus x. This value we are applying in the second one, xy equal to 8. So x multiply, what is the y value here? 6 minus x equal 8, correct? X multiply 6 minus x equal to 8. Now expand that bracket. X multiply 6, 6x. X multiply minus x power 2 equals 8. Hope you understood. Now all the term take together one side, okay? Better we can take to the next side. Minus x square going to next side means plus x square. Then plus 6x going to next side means minus 6x. And 8 already there, plus 8 equals 0. X power 2 minus 6x plus 8 equal to 0. So you can find the x value from here, x equal and x equal, correct? What we will do for that x value, just you can use the calculator, okay? As I told you before sections, press the mode button. After that, EQN, equation number 5. After that, you can see number 3, ax power 2 plus bx plus c, number 3. Then you can apply a number, x power 2 behind number 1, x behind number minus 6, and constant number, okay, x behind number 1, sorry, x square behind number 1, x behind number minus 6, constant number 8, so that you will get, when we are pressing equal to, you will get two number, one is 4 and second one is 2, x equal to 4 and x equal to 2. I hope you understood that one, okay, x equal to 4, x1 equal to 4 plus equal x2 equal to 2, like this. Okay, so x number we got. What are the x number? 4 and 2. Now when x equal to 4, just to calculate what is the y number. When x equal to 2, calculate what is the y number. So x equal to 4, apply here. 6 minus x, correct? 6 minus x means 4. 6 minus 4 means 2. So y number is 2. Now same way the second one, 6 minus x, x means 2. So we will get 4. So y equal to 2 and y equal to 4. So these are the values of x and y. X equal to 4, y equal to 2. X equal to 2, y equal to 4. And z already we calculated here, z equal to 0. I hope you understood this question, how to do. Simplification you can do by calculator, as I told here, same way. Okay, now let me go to the question 1, third part. Question number 1, 3. Okay, find the values of x, y and z from the following equation. Find the values of x, y and z from the following equations. Okay, so same like this matrix equal to this matrix, correct? So we can start first number x plus y plus z equal to 9. Second one, x plus z equal to 5. Y plus z equal to 7. Okay. Now we need to simplify one by one. Y plus z equal to 7. Now we will calculate one by one. For example, y plus z, what is the value? 7. Correct? Apply here in the first. Okay. That means x plus. See, instead of this y plus z, what we apply? 7. Y plus z value is 7 equal to 9. I hope you understood. Y plus z value is 7. That 7 means x plus 7 equal to 9. That means what will be the x? 9 minus 7. Plus 7 take to next side. 9 minus 7. That means x equal to 2. Correct? 9 minus 7. X equal to 2. I hope you understood that first one. Now we will go to the x value. Now x value apply in the second equation here. Okay, x value apply here. That means x plus z equal to 5. X means 2. So 2 plus z equal to 5. So z means plus 2 take to next side, 5 minus 2. That means z equal to 3. Hope you understood. Now, so x value we got and z value also we got, correct? Now apply that number in the last one here. Y plus z equal to 7. That means y plus what is z? 3 equal to 7. That means y equals 7 minus 3 equal to 4. So y equal to 4. So we got x number, we got y number, and we got z number, that one. Okay, so little logically we can do that question, or we can use the calculator. The same question we can do by calculator. I will show here. That means x plus y plus z equal to 9, and x plus z equal to 5, and y plus z equal to 7. Y plus z equal to 7. See, the same question without simplification, directly we will get a calculator also. Okay, you can press the mode button. After that, equation number 5. After that, anx plus bny plus cnz equal to dn. Because here we need to calculate 3 values, x, y, z. So this is number 2. So calculator will ask what is your first equation, x behind number 1, y behind number 1, z behind number 1, right side number 9. Press equal. Second equation, x behind number 1, but there is no y, so 0. Z behind number 1, right side number 5, press equals. Third equation, x, there is no x, so 0. Y behind number 1, z behind number 1, right side number 7. So once you are entering this one, press equal to, you will get what is x, what is y, and what is z number. Correct? Same numbers you got. X equal to 2, y equal to 4, and z equal to 3 here. Okay. So this is also easier idea by using calculator, the same question. Okay, now let me go to the next question. Question number 2. A equal to matrix minus 3, 8, 6. B equal to matrix 2, 0, 5. C equal to 4, 4, minus 9. Evaluate A plus B minus C first. A matrix plus B matrix minus C matrix. Correct? What is A matrix? Minus 3, 8, 6. Plus B matrix 2, 0, 5. Minus C matrix 4, 4, minus 9. So we can calculate like equal. First two matrix we need to add. Third matrix number subtract. So minus 3 plus 2 minus 4. First number. Correct? First two number add, third subtract. Now 8 plus 0 minus 4. 6 plus 5 minus 9. Correct? So you can check what will be the answer. Equals matrix, okay, minus 3 plus 2 minus 4. So you will get minus 5 matrix. Now second one you will get 4. Third one 6 plus 5 plus 9, okay, minus. So it will be 20. So this is the matrix A plus B minus C. Now we need to calculate 6A minus 5B. Correct? 6 times matrix A minus 5 times matrix B. So 6 times you can write what is matrix A minus 5 times you can write what is matrix B. So A means minus 3, 8, 6. B means 2, 0, 5. 2, 0, 5. So you can get the number. You know how to multiply a number, a matrix. So you can apply that one. Multiply the number and matrix. 6 multiply minus 3, minus 18. Okay, then 6 multiply 8, 48. Then 6 multiply 6, 36. 5 multiply 2, 10. 5 multiply 0, 0. 5 multiply 525. Minus I am putting same there. Now you can subtract so that you will get, okay, minus 8 minus 10, minus 28. 48 minus 0, 48. Now 36 minus 25, that means 11. So this is the matrix 6A minus 5B. I hope you understood the question. Now we will go to the next one. Question number 3. Compute the following product. Compute the following products. Product means multiply. We need to multiply here these two matrices. Okay, multiply. Compute the following multiply products. So this is the A matrix. This is the B matrix. Correct? Now, first we check multiply possible or not. A matrix order. You can see what is the order of A matrix? 2 by 2. 2 rows and 2 columns. B matrix, what is the order? It is 2 rows but 3 columns. Correct? So, is it possible multiply? Yes, because here second number, first number same. So, what will be the AB matrix order? First and last number, 2 by 3 matrix. Correct? So, now we need to calculate this one. A multiply B equals, we will go this 2 by 3 matrix, 2 rows but 3 columns, column number 1, column number 2, column number 3, because answer should be a 2 by 3 matrix. So as I told you before questions, first row column number 1, first row column number 2, first row column number 3, then second row column number 1, second row column number 2, second row column number 3. We need to find these 6 numbers. Okay, we have to find these 6 numbers. Okay, now we will start the calculation. So first row number 1 multiply column number 1. What is the row number 1? This is the row number 1. First matrix, first row. Second matrix, column number 1. So matrix 1 minus 2 multiply matrix 1, 2. Okay, so first number with first number, 1 multiply 1 plus second number with second number, minus 2 with 2. So 1 minus 4, we will get minus 3, first number. So we can write here minus 3. Correct? Now R1 with C2, column number C2. So 1 minus 2, column number 2 means 2, 3. This is C2. Matrix column 2, 3. So we will get 1 multiply 2 plus minus 2 multiply 3. You can check the answer, that is 2 minus 6 minus 4. So here we got minus 4. Now same way R1 with C3, column number 3. That means matrix 1 minus 2 with column 3 means 3, 1, column number 3, 3, 1. So we will get 1 multiply 3 plus minus 2 multiply 1. That means 3 minus 2. 3 minus 2 means 1. So here number is 1. I hope you clear the first row. Now same way second row we will do. Second row means 2, 3. Correct? R2. This is the second row. So 2, 3 multiply, that means R2 C1. R2 means 2, 3. Multiply with column number 1. 1, 2. Correct? So first number 2 multiply 1. Second number 3 multiply 2. That means 6 plus 2, 8. Then R2 C2. Second row means 2, 3 with column number 2. Column number 2, 2, 3. So 2 and 3. So we can write 2 multiply 2 plus 3 multiply 3. Correct? So we will get 9 plus 4. That means 13. Same way R2 C3. R2 means second row same 2 3, multiply with column number 3, 3 1. So 3 1. So we will get 2 multiply 3 plus 3 multiply 1. So 2 multiply 3 6, 6 plus 3 9. So 8 13 9, 8 13 and 9. This is the AB matrix. I hope you understood this question. Now we will go to the next question. We will practice one or two more. Compute the following product. Question number 2. This matrix. Compute the product. So you can see this is the A matrix, B matrix. So A matrix order 2 by 3. B matrix order 3 by 2. So is it possible to multiply? Yes, because here 3, here 3, both are same. So AB matrix, what will be the order? First number and last number, 2 by 2. So here we need to calculate AB matrix with 2 by 2, 2 rows and 2 columns. R1 C1, R1 C2, R2 C1, R2 C2, correct? Because we have 2 rows, R1, R2, 2 columns, column 1, column 2. So we can do this matrix. This 4 number we need to calculate. First R1 C1. What is the first row here? This is the first row, correct? Row number 1. 3 minus 1 3 with column number 1. Column number 1, this one, C1. 2 1 3. 2 1 3, correct? So first number with the first number, 3 multiply 2, plus second number with the second number, minus 1 multiply 1, plus third number with the third number, 3 plus 3 multiply 3. So 3 multiply 2 means 6, minus 1 plus 9. So we will get 14. So first number here 14. Same way R1 with the column number. Now let me go to the next one. This question. So first matrix, this one. This is A matrix, this is B matrix. What is the order of A matrix? 3 rows but 1 column. B matrix 1 row but 3 columns, correct? So multiply is possible. So AB, what will be the matrix? 3 by 3 matrix. Okay, here second, first same, 3 by 3 matrix. So now I am calculating that AB matrix. Matrix AB equal, correct? Matrix AB equal 3 by 3, R1 C1, R1 C2, R1 C3, R2 C1, R2 C2, R2 C3. Now R3 C1, R3 C2, R3 C3, correct? Okay, now equal to the matrix. What is the first row? First row means 2, that is R1. First column means 1, C1, correct? So 2 multiply 1, only one number, so only we can write that number 2. Now R1 C2, C2 means this one, second column, 2 multiply 3, 6. R1 C3, third column, so 2 multiply 6, 12. Hope you understood. Now second row, go to the second row, this is the second row, R2. So minus 1 with 1, minus 1, minus 1 with 3, minus 3, minus 1 with 6, minus 6. Then need to go the third row. Third row means 3, only number 3. So very easy to find. 3 multiply 1, 3. 3 multiply 3, 9. 3 multiply 6, 18. So this is the 3 by 3 matrix. After multiply we are getting. Hope you understood that question. Now question number 4 here. Okay. So question number 4, this is the A matrix, this is the B matrix. A is a 3 by 3 matrix, B also a 3 by 3 matrix. So AB we need to calculate. First we check multiply possible or not. Here 3, here 3, so it is same. So answer matrix is 3 by 3, first number and last number. This is the answer matrix order AB. So we can go to that one. A multiply B matrix equals matrix. Okay, first we need to do R1 C1, R1 C2, R1 C3, R2 C1, R2 C2, R2 C3, R3 C1, R3 C2 and R3 C3. Now I hope you got the idea how to multiply. So no need to write more steps, you can do that multiply. First R1 C1, first this is the R1, first row, multiply with this is the column number 1, correct? So 1 multiply 0, that is 0, 2 multiply 2, 4, plus 0 multiply 1, that is 0, correct? So totally we will get 4. You can write the answer here, you can check by calculator. So 4. Now R1 with second column, column number 2, correct? 1 multiply minus 1, that is minus 1, 2 multiply 2, that is 4, 0 multiply 3, that is 0. So minus 1 plus 4 means 3. Now the first row with the column number 3, this is the column number 3. So 1 multiply 2, that is 2, 2 multiply 4, that is 8, 0 multiply 5 means 0. So 2 plus 8, that is 10. Now go to the second row after that, row number 2 here, this is row number 2. So 3 multiply 0, 0, 4 multiply 2, 8, minus 1 multiply 1, minus 1, 8 minus 1, that is 7. Same now second row with the column number 2, 3 multiply minus 1, minus 3, 4 multiply 2, 8, minus 1 multiply 3, minus 3. So you will get 2 totally. So you can write 2 here. Now row 2 with the column number 3, 3 multiply 2, 6, plus 4 multiply 4, 16, then minus 1 multiply 5, minus 5. So you will get 17. Hope you understood before questions. So here I am just writing only the numbers, you can check by calculator. Now third row, R3, 0, 6, 2, multiply with the first column, 0 multiply 0, 0, 6 multiply 2, 12, plus 2 multiply 1, that is 2, correct? So 14, can write 14. Now R3 with C2, 0 multiply minus 1, 0, plus 6 multiply 2, that is 12, plus 2 multiply 3, 6, so 18, we can write 18. Now third row with C3, 0 multiply 2, 0, 6 multiply 4, 24, correct, plus 5 multiply 2, that is 10, so 34. So we can write 34. So this is the corresponding 3 by 3 matrix. Hope you understood this question. You can do by calculator for practice later. Okay, now let me go to the next question. Question number 4. Question number 4. Now this question, can we multiply A matrix 3 by 2 with B matrix 3 by 3? A matrix 3 by 2, matrix B 3 by 3. Can we multiply these two? No, because here number 2, here number 3, not same, correct? So answer is no. Now question number 5. What is the order? Find the order of AB matrix. A matrix order 5 by 2. Matrix B order 2 by 3. So we need to calculate what is AB matrix order. Okay. So first we check multiply possible or not. Here 2, here 2. So both are same. So we can multiply. So AB matrix order means the first number here, the last number here, correct? So what will be the order? 5 by 3 matrix. 5 by 3 matrix. Hope you understood this question also. Just multiple choice questions. Now next question. Go to this one. Given that, okay, given that A equal to this matrix, B equal to 1 matrix, verify that A plus B all transpose should be same as A transpose plus B transpose. Verify. Verify means this is the left hand side, this is the right hand side. So left hand side and right hand side should be same or not. That is the question here. So we will do this question. First we will do what is the left hand side we are getting. Then we check right hand side what is the answer. So check the same or not. So what is the left hand side? A plus B matrix first we need to calculate. Then after that transpose. You know what is A plus B matrix? Just add these two matrix. First number with the first number. So minus 1 plus minus 4 minus 5. 2 plus 1 3. 3 plus minus 5 minus 2. 5 plus 1 6. 7 plus 2 9. 9 plus 0 9. Minus 2 plus 1 minus 1. 1 plus 3 4. 1 plus 1 2. This is A plus B matrix. We studied this section correctly. A plus B. Now A plus B matrix transpose, that is the left hand side. Transpose of this matrix, correct? How to find the transpose? Take the first row, write it as first column. What is the first row? Minus 5, 3, minus 2. We are writing first column. Second row, 6, 9, 9. Write it as second column. Third row, minus 1, 4, 2. This is the third column. So this is the left hand side. A plus B transpose. Now we will check the right hand side. What is A transpose plus B transpose equal? Correct? A transpose plus B transpose equal to. So first write what is A transpose matrix plus then we can write what is the B transpose matrix. What is the A transpose matrix first, right? A matrix write in the transpose, rows write column wise. So first row minus 1, 2, 3, first column. Second row 5, 7, 9. Third row minus 2, 1, 1. Same way B transpose, B matrix rotate. So minus 4, 1, minus 5. 1, 2, 0. 1, 3, 1 third, correct? Now after that add these two matrices. So we will get matrix, first number minus 1 plus minus 4 minus 5, 5 plus 1 6, minus 2 plus 1 minus 1. Same second row, 2 plus 1 3, 7 plus 2 9, 1 plus 3 4, 3 plus minus 5 minus 2, 9 plus 0 9, 1 plus 1 2. So now we can check these two matrices are same or not. It is same, correct? So left hand side equals right hand side. Hope you understood this question. How to verify A plus B transpose equal to A transpose plus B transpose. Now the B part of the question. B part of the question, what we do? A minus B all transpose equal. A minus B all transpose equal A transpose minus B transpose, same or not? Okay. So same way we are doing. First we need to do the left hand side. Then we need to do the right hand side of the question. Check the answer correct or not after. So left hand side. First we do A minus B matrix. After that transpose. A minus B matrix. So you can see what is A minus B matrix. It is given in the question. A matrix is given and B matrix was given, correct? From that find what is A minus B matrix. So we can see A minus B, subtraction, minus 1 minus minus 4, so plus 4, minus 1 plus 4, that is 3. Now 2 minus 1, that is 1. Now 3 minus minus 5, 3 plus 5, 8. Now here second, 5 minus 1, 4, correct. Then 7 minus 2, 5. Then 9 minus 0, that is 9. Now third row, minus 2 minus 1, minus 3. Then 1 minus 3, minus 2. Then last number, 1 minus 1, that is 0, correct. So we go to what is A minus B matrix. Now A minus B matrix transpose. A minus B transpose equal to, just rotate this matrix, write rows like columns. So first row, you can see the first row here, 3, 1, 8, first column. Second row, 4, 5, 9, second column. Third column, minus 3, minus 2, 0. Hope you understood what is A minus B transpose. Now the right hand side now. Okay, right hand side we will calculate. Right hand side means A transpose minus B transpose, correct. So A transpose minus B transpose. So first write the A transpose matrix here minus B transpose matrix here. Okay, first A transpose. Okay, I can write here minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. Just before we wrote the same one, A transpose, and B transpose also minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1, correct. Now A minus B matrix, sorry, with the subtraction of these two matrix, matrix minus 1 minus minus 4, minus 1 plus 4, that is 3, 5 minus 1, 4. Like you can complete all, you will get the same matrix, correct. So what is, we have left hand side same as the right hand side. So this is the idea in the second part. I hope you understood this question. Now the third part of the question. Okay, third part we need to do 5 times A transpose equals 5 multiply A transpose, both should be same. Okay, this is we need to verify from the third part. So left hand side we can do, right hand side we can do here. So first left hand side, first we need to calculate 5A matrix. So 5 multiply matrix A means minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. So you know how to multiply a number, a matrix, correct. All the number we need to multiply the outside number. 5 multiply minus 1, minus 5. 5 multiply 2, 10. 5 multiply 3, 15. 5 multiply 5, 25. Then 35, 45, minus 10, 5, 5. Correct. All the number multiplied 5. Now 5A matrix transpose equal. Just to rotate this matrix, write rows column wise. First row minus 5, 10, 15, first column. Second row, write second column, 25, 35, 45. Then third one, minus 10, 5, 5. So this is the left hand side. Now right hand side we are doing. Okay. So right hand side what we need to do? 5 times A transpose. So first write what is A transpose matrix. A matrix rotate. So we can write minus 1, 2, 3. second row 5, 7, 9, minus 2, 1, 1. Then after that we do 5 multiply A transpose equal. So each number multiply with 5, the outside number. Okay. So we will get 5 multiply minus 1, minus 1, minus 5, then 25, then minus 10, then 10, 35, 5, 15, 45 and 5. Correct? That means the left hand side equals the right hand side. That is just for practice only, these questions, how to verify these identities. Okay. Now we will go to the next question now. Hope you understood these questions. Question 7. Now some important ideas again we are doing: symmetric and skew symmetric matrices. So for example, this matrix, which of the following matrices are symmetric and which of the following matrices are skew symmetric? That is the question. Symmetric matrix, skew symmetric matrix. For example, this is the A matrix. Okay, just to calculate what is A transpose so that we can identify. A transpose equal, just to write row column wise: 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. Correct? This is the transpose. Write rows column wise. Now check these two same or not. These two matrices are same or not. Both are same. Correct? Both are same. That means A equals A transpose matrix. Means what is the meaning? Symmetric. Symmetric matrix. So A and A transpose matrix same means we are calling it as symmetric matrix. Now the B part of the question. Okay, B part. For example, this is the A matrix. Calculate A transpose matrix here. Calculate the A transpose. What happened? Matrix 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Now compare these two matrices. Is it same? Not same. See, because 0 first number, here also 0. 1 become minus 1. Minus 1 become 1. Minus 1 become 1. 0 same. 1 become minus 1. Just to opposite number. That means A transpose not same but minus of the A matrix. A matrix opposite. Minus A. Okay. A matrix opposite. That means this matrix is skew symmetric. Correct? Skew symmetric. Skew symmetric, as I told you, how to identify that one easily? Just to take the diagonal number. Diagonal number should be 0 there. Skew symmetric. Okay, now we will go to the 7C part of the question. Symmetric, and which are the symmetric matrix, which are the skew symmetric. So first one, this is the A matrix. Just to calculate what is the A transpose. Equal matrix. First row become first column. 6 minus 2, 2. Minus 2, 3, minus 1. 2, minus 1 and 3. Check, is it same or not? Same. Both are same. Correct? So A equals A transpose. Means the matrix is symmetric. Hope you understood what is the idea behind symmetric and skew symmetric. Now we will check the second one. Now D, question number D, symmetric or not. This is the A matrix. So calculate A transpose matrix. First row become first column, 2, 16. Second row 16, 4 become second column. Now check same or not. Both are same. Correct? So A equals A transpose. So symmetric. Symmetric matrix. Now question number E. Question number E. 0 minus 2, 2, 0. So this is the A matrix. It is clear actually diagonal numbers are 0, but we can check. A transpose equal matrix. First row become first column. Second row become second column. Now you can check these two matrices. Both are not same, but it is opposite. Correct? 0 minus 2 become 2. 2 become minus 2. 0 becomes 0. So what we can write, A transpose and A are not same but minus of A, opposite of A. That means Q symmetric. That matrix is Q symmetric. So I hope you understood what is the meaning symmetric matrix and skew symmetric matrix. Okay, now let me go to the question number 8. For a matrix A equals 1, 5, 6, 7, verify that A plus A transpose is a symmetric matrix. A plus A transpose. In a matrix, A plus A transpose will be always symmetric. So we need to verify that one here, this matrix. So just calculate what is A plus A transpose matrix first. Okay. So A matrix means 1, 5, 6, 7 plus A transpose matrix, transpose of A, 1, 5, 6, 7, rotating, correct? Now add these two matrix. So matrix 1 plus 1, 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14, correct? Now what is our question? This matrix, okay, this matrix, whatever you got, symmetric or not? Okay, this matrix symmetric or not? For example, I am giving this matrix is C. I am giving C. Just calculate what is C transpose. Transpose of that matrix. Matrix, what is the transpose of this? 2, 11, first row, first column. First row, write it as first column. Second row, 11, 14, second column. Now check these two matrix, C matrix and C transpose matrix, same or not? Same, correct? Both are same. That means what we can say, A plus A transpose, that means the C matrix is a symmetric matrix. Hope you understood this question. Just calculate A plus A transpose matrix, then check that is symmetric or not. Rotate that matrix, getting same or not. Okay, that is the question. Now question number 9. Okay, question number 9 here. If A equal to sin x, cosine x, minus cosine x, sin x, verify that A plus A transpose equal to the identity matrix. Verify means left hand side when you are doing, you can get right hand side or not. That is the question. Okay, I, this is I, not 1, I. So I means, what is the meaning I? Identity matrix 1, 0, 0, 1, because 2 by 2 here. A matrix is 2 by 2. So I matrix also 2 by 2 matrix, 1, 0, 0, 1. So A transpose multiply A matrix, when you are multiplying, you will get this or not. That is the question. Verify that one. You are getting 1, 0, 0, 1 matrix or not. Okay. So we will go to that one. So A transpose multiply A matrix equal. Okay. What is the A transpose matrix? A matrix, just rotate. First row sin x and cosine x, write it as first column. Second row minus cosine x and sin x, write it as second column. A transpose matrix. Multiply A matrix. A matrix means the same. Sin x, cosine x, minus cosine x, sin x. Correct? Now we are studied how to multiply these two matrices. This matrix and this matrix, how can we multiply? We studied that one, correct? So what we do for that? This is the first row, second row. This is the column number 1, column number 2. So first row with the column number 1, first row with the column number 2, second row with the column number 1, second row with column number 2, correct? We need to calculate these 4 numbers here. Okay, so we will do first R1 C1, first row with the column number 1. What is the first row? Sin x minus cosine x. Sin x minus cosine x. Multiply with first column. First column means sin x minus cosine x. Sin x minus cosine x. Correct? Now multiply these two. What you will get? You can check. First number with the first number. Sin x multiply sin x plus minus cosine x multiply minus cosine x. Correct? Sin x multiply sin x means sin square x. Sin square x. Sin multiply sin square x. Minus minus become plus. So already here plus. Cos multiply cos means cosine square. Cos square x. Now what is sin square x plus cos square x? It is 1. We are studied the trigonometric identity. Sin square x plus cos square x means value is 1. So the first number we got here, it is 1. Okay. Now R1C2, first row with column number 2. What is the first row? Sin x minus cosine x. Multiply column number 2. You can see what is column number 2, cos x and sin x. Cos x and sin x. Multiply first number with the first number. Sin x cos x plus minus cos x sin x. So what will be the answer? Sin x cos x minus cos x sin x. Same term but opposite sign. See, sin cos. Here also sin cos. Here plus, here minus. So what will be the answer? 0. Correct? Cancelled both. 0. So second number also we got 0. Now R2C1. R2C1. R2 means cos x and sin x. So we can write cos x and sin x R2. R2 with C1. R2 means cos x and sin x. With C1, column number 1. What is column number 1? Sin x minus cosine x. Sin x minus cosine x. Multiply this one. So we will get cos x multiply sin x, first number with the first number, plus second number with the second number. Sin x multiply minus cosine x. Correct? So here also see, first bracket sin and cosine. Second bracket also sin and cosine. Second bracket is minus. So it will cancel. Value becomes 0. Same term but opposite sign. Now lastly R2C2. R2 means cosine x, sin x, multiply C2, column number 2 means cos x, sin x. Cos x and sin x. Multiply here. So cosine x, first number, multiply first number cosine x, plus second number sin x, multiply second number is sin x. Cos x multiply cos x means cos square x, plus sin x multiply sin x means sin square x. What is sin square plus cos square? Again it is 1. We studied the trigonometric identities. Sin square plus cos square is 1. So what number we got here? Here 0, here 1. Correct? So left side we are started with A transpose multiply A. We got what answer? 1 0 0 1. 1 0 0 1 means the identity matrix. Correct? So that means left hand side equal to the right hand side, because right hand side also identity matrix. Same identity matrix here we are getting answer. So left hand side equal to the right hand side. I hope you understood this question. We can practice one by one. So this section 2.3 we are studied many ideas, basic operations of the matrices and special types of matrices and transpose of a matrix, correct? And related to the related questions. I hope you understood this class. Thank you for watching. Please subscribe my channel. Thank you.